All right. Welcome everyone to this the third session of our discussion on GPS triangle racing. I hope you're all doing well, and I hope you're getting out and doing a bit of flying now. And wherever you are in the world is, you're changing, hopefully changing back into what's a new normal life. It's good to be doing our third one. From the land of the long white cloud and one of the greatest countries in the world, we have, as usual, Dave Griffin. He's doing our housekeeping here for us for the third session. How you going, Dave?
Hi, John. Thanks for inviting me. I really enjoy it.
No, I really appreciate you. Keep things running smoothly, and it's good to see you again. So I hope you're going well, and you've been doing a bit of flying.
Yeah, I had a day out this week doing some triangles, trying to get the hang of it from what I've learned from you guys and Daniel and Philip's session too, and Andre. Trying to put it all in practice. Yeah.
Yeah, no, I've listened to a few of those. Those sessions have been really good. Andre's one last week, and he's got another one coming up this week. Is really good for everyone who uses Albatross and all his gear, basically. Also, we've got our special guest all the way from the UK, John Greenfield. Thanks again.
Hi, guys.
Thanks again for being part of it, John. We had some good feedback from the last session. And how's your week been?
It's been very good, actually. We've had finally some decent flying weather here in the UK. So myself and some of the other UK guys have managed to get out and do a bit of flying this week.
Yeah.
Posted our scores up on the league, which all looks rather nice.
Yeah.
But today, it's gone back to a typical UK weather, blowing a gale.
Oh, okay. All right. So we'll get on with it. So this session is going to be about, as you understand, these sessions that I've been doing are designed to encourage people to take up GPS racing. So they're designed for beginners. I know we've got some people who have been flying models for a long time involved, and hopefully you'll get something out of it. But I'm basically just talking from the experiences that I've had doing GPS, and I've been doing GPS, for about 7 years. And as I've said in the first one, I fly basically on my own and self-taught, so I've had to sort of work things out for myself. So I just thought I'd share some of that experience of how I've worked these things out. So GPS flying is a lot different than a lot different experience for aero modelers that haven't flown, say, listening to telemetry. And you need to have everything on your side to be able to concentrate on the task at hand, which is, in the end, flying the triangles. It does take a bit, to get to that point. Obviously, as you guys have bought gear and now trying it, I've heard from a few of you over the last few weeks. It does take a bit to get your head around, but once you get your head around, ultimately you just want to get out there and concentrate on flying the best triangles you can. So, the less distractions you have, the easier it's going to be, and the more efficient you're going to be at flying those triangle tasks. I was driving along in the car the other day, and it sort of come to me that it's a lot like if you're driving. I'm sure all of you have driven a car using a GPS, looking for a destination that you're not sure where it is, right? And you know that you've got to concentrate, especially if you're in a city. You've got to concentrate on the traffic. You've got to concentrate on the information that's being fed to you. But if you've got a distraction in the car, such as a fly flying around, or your wife in the background, or someone telling you there's a shorter route, you know how off-putting that is. And, it's very difficult to react to the information that you're being fed from the voice to the GPS, because you don't have the full concentration. So it's exactly the same with GPS flying. You've got the distractions all around you, and they can be anything from your GPS info not being set up correctly, sunscreen dripping in your face, headphones falling off your head, and this is all talking from experience. Being able to not being able to hear your helper if you're fortunate enough to have a helper, poorly flying sailplane, losing sight of the sailplane, not knowing if you've switched a mix switch on, worrying about a battery that could be going flat due to an undercarriage or a self-launch leg not retracted. And that's just a few of the things that can go wrong. So you can have there's lots of things you've got to think about. So my setups for myself have been done from necessity. Most of my flying is done at home here, but I'm fortunate enough to have a flying field very close to my house. It's done over the Christmas period, whereas for those of you who don't know, like in Australia, around that time of the year, it gets extremely hot. So we can have temperatures up to 48 degrees. But with that weather also comes some fantastic GPS weather. So originally when I started flying GPS, my cutoff temperature was about 38 degrees, but I have been known to go out if there's a big cumulus nimbus cloud out there at about 42. My wife actually took a photograph of me standing out in the paddock once when it was 42, but she thought I was going to pass out. But it was just crazy, but the weather was just phenomenal. And I think in that sort of weather, I think I managed to get 17 laps. So, you know, I felt at the time it was well worth it because I was just after the big laps. So the way to go out in that weather for myself, the way my day started is I did a bit of pre-planning because I was basically on holiday, so I could do a bit of pre-planning. So the first thing, I'll just share my screen with you. If you allow me to. Just bear with me for a second. So the first thing I'd do in the morning is I'd have a look at the full-size glider weather website. And from that, I could sort of judge what time of the day the thermals are going to break around my area, because it was sort of, Waikeries are a pretty known full-size glider area. So I'd sort of roughly know when I was going to go out flying if I wanted to catch the big weather. Usually that was around like 12 to 1 o'clock in the afternoon. Then if I knew I was going flying about 12 or 1 o'clock, then what I'd start doing is hydrating myself in the morning, getting plenty of liquids into me. I didn't like wearing suntan. I didn't like wearing sun cream because, as I said, it drips in your face and gets all over your hands. So I wore sun-appropriate clothing. Again, looks a bit crazy, but you do what you got to do. And I'd obviously have sunglasses on there, and I'd have gloves on and all that. I would use things such as light headphones under that, so I was all prepared, ready to go. I'd have everything charged, radio, batteries, phone, etc. I'd have the sailplane assembled, obviously, way before that. I usually leave it assembled overnight. We've got a workshop big enough to do that, fortunately. I'd only get changed into these clothes if it was hot. Say if it was it's not always 38 degrees in Australia, but if it was 38 degrees in Australia, I would get changed in those clothes at the last minute, and then I'd probably wet them down. I'd wet the hat down and wet my shirt down, have a drink, and then I'd go out. So if it was 38 degrees, I could probably last out in the paddock for maybe a couple 30 minutes. So 2 30-minute flights was usually about an hour and a half sort of work. 42 degrees, you're struggling to do one 30-minute flight because the heat just gets to you, your clothes will dry out and you get too hot. So then I'd come back home and I'd drink probably a litre of Gatorade and just take it easy for an hour and wait till probably the next day or later in that day. Might do some trim testing or something later in that day. So you can imagine in these conditions that everything needs to be working smoothly. You can't be getting out in the middle of the paddock in that sort of heat and be trimming your glider or setting your gear up or doing everything like that. So you do basically take the glider out there, do a quick control check, and off you go. Okay. So for that to happen, a big part of being ready is to have your sailplane well sorted and be reliable to fly triangles. So I want you to understand that everyone's got a different way of doing things, obviously. So I'm just telling you the way that I did this, but I think this can apply to most airframes and gliders I've had since this one. But this glider here, the ASH 26, is the first glider that I used for GPS. It was a scale glider that I had for a few years. John's been fortunate enough to fly it. I don't know if it's fortunate enough, but he's had a lot of fun. We've had a lot of fun with it. So that was basically a 6-metre glider that I'd scratch built, had foam core wings with Obechi, and the wings were covered to keep the weight down. As I said, it was set up originally as just a scale glider, and it served its purpose. I flew it for a few years just as a scale glider, and as I said in the first session, you know, got a bit sick of just thermaling and all that, so I got talked into GPS. So I had to have a bit more of a critical look at it, basically, to get it to do GPS. Because I mean, with a scale glider, you basically just you know, you have the thing so it flies well. You've got the CG set up, which I would call now roughly. At the time, I thought the CG was set up really good, but it was the CG was set up sort of roughly at the time, enough that you could it would take off, it would fly around well on the, you know, after the tow, and it would land nicely, right? So, but the thing is with GPS flying is you've got to have it so it flies very efficiently, or as efficiently as that airframe can, and it's got to fly well in a straight line. So the first thing you do, like the first thing I did with it, is had a critical look at the airframe basically, and thought that you know, what can I do to basically clean this airframe up? And on this particular glider, being foam core Obechi wings, the trailing edge was a little bit thick. So the first thing I did is I pulled all the control surfaces off and thinned the trailing edge down, recovered them, reattached them. I put gap seal tape on everything. I completely covered. I glued all the servo covers in and completely flushed them right off. I had fairings over the push rods, all those sorts of things. And then also I removed any unnecessary weight out of the fuselage. So things such as cockpit trays and all that. If that wasn't going to affect the CFG, I'd remove it all just to keep the weight down. Obviously, you're not going to want it as light as possible, but you can always put weight back in, as you'll know. Then I looked at, because as I said, I predominantly fly on my own, I looked at putting a self-launch unit in it. So you've either got a pop-up type, which we've discussed that, which that's one I actually put in that there. Or nowadays we've got the more popular, which is the nose drive. This is a picture of a Hacker removable nose drive that you can buy without the propellers on it. This is the one that I've got in my current glider. I'm doing a few modifications to that. Yeah, so then if you've got the nose drive or the self-launch system, then you can actually you know, go out flying anytime on your own, which gives you that freedom. The next thing was I noticed with this glider is when I did fly it, I could lose it when it got it high, and from what I've seen since I've been doing GPS, is probably one of the things with GPS gliders is that they're quite easy once you start getting high to lose sight of it, and or get mixed up with someone else's glider and end up flying someone else's glider. And I've seen that happen. So what I did with it is I put some visual aids on the bottom of it, and I've found that as you can see with all my gliders, I've found that stripes are probably the best. I've seen gliders that have solid solid colours under the wings, and sometimes if your mate's got solid colours too, it's hard to tell the difference. Whereas as you can see, these stick out at quite high, and you can discern it from another glider. Then the next one was making the systems in the glider easy to use. So easy to switch on the RC gear, and this again is because I'm going out flying in this hot weather, but also if you're going out flying, you don't want to be mucking around out in the field with switching things on and having difficult switches to get. So I made it easy to switch the RC on. I made it easy to connect the motor batteries up, and also easy to understand where all your switches are on your radio. Now, for me, again, that was a learning curve for me, because I would just set my gliders up and I'd know I'd have my aerotow released in the same spot, but all the rest of the switches were all over the shop. John fortunately come over and showed me how to set up conditions, which changed the way I flew basically, and I've adopted that ever since. But I standardise all my switches on the radio, and as I said, this may seem obvious to some people. It wasn't obvious to me at the time. I standardise all my switches, so I know if all my switches are in one direction after takeoff, that's ready to fly triangles basically, and then I've got my condition switches to go through the different conditions while I'm flying. I've got my, say for instance, I've got my landing condition is actually actuated by my flap actuator. So, you know, as soon as I'm actuating the flap, it's in landing, so I can't accidentally switch it into landing while I'm flying. Okay. The other thing was to have, the other thing I had, I talked to someone when I early got into GPS, and he told me that he'd lost his glider due to the undercarriage servo failing, and he was up high, didn't know it, battery went flat, glider crashed, quite an expensive molded glider. So that sort of, after that, he said, he put on some sort of circuit breaker, which is this thing here. So I know that you guys that fly Jetty are going to say, oh, we've already got that. Yeah, fair enough. At the time, we didn't have that. This Amcotech one here, I'm sure there's other brands available. This one here, it can either switch the control off completely when it fails, or you can put it on a timer that it times out. And it has saved my glider a couple of times. You know, undercarriages are pretty vulnerable in these things, and the servos, especially over the years, if you fly the same glider for several years, the servos can fail. And as I said, this is saved. I've also got one on my self-launch leg of my glider, and that's saved that too if the doors ever jam or something like that. But what it does, it gives you the confidence to know that when you're flying around the triangles, if something like that does go wrong, you're not worrying about that the batteries are going flat. You know, your undercarriage may not be away, or your self-launch system might be stuck through the doors, but it's not sitting there draining the batteries, so you can still go flying. And also, that went out of that. Have your GPS gear set up. So I've got you know, mine all pretty well ready to go like that. So you have all that set up so it's easy to get to. Also for the motor batteries, for the motor, I actually use one of these things. This is like a big cutout switch for the battery, so you can actually connect the batteries up to your motor, but then you've just got a pin switch in the side of the fuselage, and you can pull that out and everything's armed ready to go. So it's like a couple seconds. Also, if the other thing with a glider, if the batteries are buried deep in the fuselage and you had a fire in a particular place, yeah, there may be a chance that would protect it. Okay, that's the other thing also. All right, so that's, you know, basically how I've sort of set my gliders up, and from then on, it's all about the trimming the glider to get it ready for GPS, and that's what John's going to talk about tonight. Because as I said at the time, you know, I got to meet all these magnificent people around the world through GPS, and you know, Dave's certainly one of those. You know, we used to go over to New Zealand a few times, and Dave invited me around his house, and we got into GPS, and I've been over there a few times flying. And then, as I said, John Greenfield, fortunate enough to have him come over and stay with us, and just listening to the different idea that these people have about flying GPS and the setups they have. It's really changed things for me, especially. And I'm sure that, you know, the other Zoom sessions that are happening around the world, like Andre's and all that, we're just getting so much information nowadays. It's everyone's really running out of excuses not to get into this magnificent part of the hobby. So, John, would you like to start, and you got something to add to all that? Talk about the trimming setup before polar flying was involved. So, have you done a polar flight with the Snipe and Raven?
I haven't actually, because I haven't been using Raven recently.
Oh, okay.
My Ash 31 open class model is being refinished at the moment.
Oh, okay.
And the weather's been absolutely rubbish in the UK anyway.
Yeah.
So
yeah.
I've been flying my sport class model, which has got Sparrow in it.
Yeah.
But what I'm going to talk about is it touches on doing polar type flights without logging polars. So you can do this with any of the GPS kit available, the Sky Navigator, the Flymate, the T3000, you know, Snipe, Raven. The principles are all exactly the same, because it uses the data that's readily available to you to be able to sort of fine tune your model. But the first and most important thing is the center of gravity of your model in the right place. And the biggest issue that I see when people are kind enough to say, would I, like to fly the plane, fly their plane, is the CG out. Now, unless the CG is in the right position for that particular airframe, you're on a hiding to nothing in getting the thing to fly stably and in trim. So I just want to talk for a moment about how to check the CG. Step one, of course, is what do the manufacturer suggest? And that should be a good starting point. But they're not always correct for general flying, and they're not always correct for GPS flying. And the simplest way of checking the CG is correct is to do a dive test. Now, for those of you who don't know what that is, basically climb the plane up to a safe height, and I would suggest 300 or 400 meters. And the idea is then to push the plane over into a 45-degree dive. Now, it does help if you've got a helper here, because 45 degrees looks quite steep. But the idea is you push it over into a 45-degree dive, stabilize it in the glide, and take your hands off the elevator. And what you're looking for is a plane that slowly starts to pull out. If the CG is too far forward, the plane will start to pull out into level flight quite quickly. Now, I'll stress that again, because most people think the forward CG will make it go steeper and steeper. That's not the case. A forward CG will make it pull out of the dive fairly quickly. And if you leave it, it will then actually pull out the dive and start climbing again until it stalls. An aft CG will mean that when you push it into a dive, it starts to get steeper and steeper. Now, that's a very dangerous situation, especially when you're flying at speed. So what we're looking for isn't the zero, what I call the zero CG. So if you push it into a 45-degree dive, it just stays in that dive, flying straight down that 45-degree line until it hits the floor. That is a little too unstable as well for GPS flying. What we want is a plane that just slowly starts to pull out. And that way, it will manage its speed to a certain extent itself. The second most important thing, once you've got the CG right...
Just before you go with that one, John, the thing that you missed, I suggest, is prior to that, you have the glider so that it does fly flat and stable before you do your dive test. If it's nosing up or nosing down or whatever, just in straight flight, then that's not right either. You've got to trim the elevator to get it to fly level, then you do your dive test.
Well, thank you, William. I had assumed that you were already flying this model and it flew what you thought was straight. But yes, if the plane doesn't fly what you think it is straight to start with, then this dive test won't work. So thank you, William, for adding that in. Once you've done the dive test, the next thing to check is where your controls are relative to the surfaces. So have you ended up with the elevator up or down relative to neutral? And also, any of the other controls, are they deflected? Because any control surface that's deflected into the airflow is creating drag. So we need to address any issues in that respect in terms of twists in the wing, wings out of alignment, tailplane incidents, or whatever else, so that next time you do this dive test, the thing actually flies as you want it to, with all the controls centered. Now, I don't mean the trims on the transmitter centered, I mean the physical controls on the model. I've seen several aircraft, probably because the molds were done and then they did the test flying and never went back again, where the tailplane incidences are completely wrong, often out by several degrees. So you'll find you've achieved what you want as best you can with the dive test, but it's flying with up elevator or down elevator in it. Well, of course, that will change its effectiveness as you fly at different speeds. And as we're going to be flying GPS models at quite a wide range of speeds, it's important that all the controls are centered. So this may be a case of having to go around this several times. Do the dive test, as William said, make sure you think it's flying basically straight to start with. Do the dive test, see where the controls are, make the necessary adjustments, come back, do it again, make the necessary adjustments, come back and do it again. Now, this should all be done in what is the normal flight mode. We're not going to touch on flight modes here at all at the moment. This should all be done in normal mode or the standard mode, because we've got to get the basic settings of the aeroplane right before you start playing with flight modes. If you've already enabled all the flight modes and separated the trims and everything else that goes with it, then you've actually got to remember to do all your adjustments in each flight mode each time. So the best thing to do at this stage is switch them all off and get the plane to fly correctly first of all. Once you've got this thing actually flying like you think it will, the best it will do, then you can actually switch the flight modes on, not forgetting to separate the trims, of course. And now we can start trying to dial in each of the modes. Now, I'm going to talk only about 3 modes at the moment. That's normal, that's your normal glide, a speed mode where the plane will fly faster, and a thermal mode where it will actually fly slower, so you can loiter in thermals. Now, many people have speed 2. I fly with a thermal 2 setup, and we can talk more about that later on. So first thing is, we'll do all the settings for normal mode. Now, if you've got the central gravity right, you've got the lateral balance right, and all your controls are in the middle, then that's a very good starting point. And the way I actually check to see how good the glide is, and again, it helps if you can have a helper for this, but when I started GPS flying, nobody else was into it at all, so I did it myself. So I know that it's actually relatively simple to do. Using the data that's available on the screen, I fly out as far as I can reasonably do. With a sport class model, obviously you can easily get out as far as the turn point, so that's 350 meters. But what we're looking to do on a calm day, and you may well have to wait some considerable time to find a calm day, or get up very early in the morning when the air's still. Some countries very late at night it will go cool as well. The idea is to fly out as far as you're reasonably happy, turn around, start flying back towards yourself. At that point, check your altitude and your speed. This is where a helper can help because you can actually write it down. But basically, a quick glance at the screen, look at your altitude, look at your speed. And then let the plane fly hands off.
So
it's important.
Usually, John, you're flying along the long line of the triangle, aren't you? You usually, I'll just put this diagram up that I spent a lot of time drawing. Usually, when I after you told me how to do it, normally I'd be standing here, right, and I would fly. You can see my cursor there, can you, John? Yeah. Normally I'd be standing here on the start line, and I'd fly out just the way my airfield's set up and the weather. I'd fly out beyond turn point 3. So if you're flying scale class, this would be 500 meters. I'd turn around, come back as it goes through 500 meters. I'd mark it on, I'd say that would be the mark on the T3000, and then measure it from there. Yeah.
Yeah, that's fine, John. Assuming you've got sort of 0 wind conditions.
Yeah.
If the wind is across the course, then this is it needs to be very light wind to do this. But basically, I try and make the flight into wind. If the course lines up with the wind, that's great. But you need to fly in a straight line. If you're trying to do this and there is a slight crosswind, then the drift of the plane across the sky will tend to muck up the test a little bit. So if you're doing it in calm conditions, it really doesn't matter what direction you fly. But yeah, if you can align yourself along the course, and then it does help, and it's good practice as well. But what we're trying to do is let the plane fly for as long as possible in a straight line with minimal to no control inputs, noting the flying speed and the height at the start and the finish. Now, using the course has its advantages because then you've got a known distance that you've flown over. but actually there's information inside your GPS that tells you distance to turn point and distance away from yourself. So you can also use that. And the whole idea of this, and bearing in mind, this will take many, many flights to fine tune, you will find a situation where with adjustments to the elevator trim, hopefully you shouldn't have to touch the C or G again, but if you start having to play with the C or G, you've got to go back and do all your dive tests again. But what we're looking for is a plane that will glide at constant speed, at a constant rate of descent, that's the minimum that that rate of descent will be without the plane starting to porpoise or wander. Now, by porpoising, I mean the nose slightly raises, then it drops again. Raises, drops again. If the C or G is correct, that is generally because the plane you're trying to fly it too slowly. So there's a little bit too much up elevator in it, and therefore it's trying to climb against gravity. As it's trying to climb, of course, the speed decays a little bit till the wings won't support the weight anymore. Then the nose drops, so the airspeed starts building up again, which makes the elevator more effective, and slowly it rises up again. Porpoising is the last thing that we want because it's very inefficient. So if in these tests you see the plane is porpoising, then what you need is a little bit more down elevator. If you end up with the elevator deflected too far relative to the aerodynamic neutral, then you might need to go back and redo your C or G checks. But you should find a situation with any airframe where the plane will just fly along at a constant rate of descent. And that's the optimum thing we're looking for. Now, to put this all into perspective, I would reckon with a new plane, I'd probably make that test distance 30, 40 or 50 times in order to get the plane dialed in. So this isn't a nip out for half an hour in the evening or morning type situation. It takes a long time with fine adjustments to get this thing dialed in. Once you've got it dialed in, now you've got the basic settings to be able to expand to the other flight modes. So those settings should be copied to the other flight modes. And now you can start doing the whole thing again with it in speed mode, which generally with a GPS type model would mean raising the flaps to reduce the camber on the wing and balancing that with an offset of the elevator. Again, we need the elevator offset to be an absolute minimum commensurate with the camber changes, because we don't want to introduce unnecessary drag on the airframe. Again, start with the manufacturer's recommendations, but don't take them as absolute gospel, because often the manufacturer has dialed something in that works for them for normal flying, and actually you might want something different for GPS flying. So again, it will take quite a bit of time and effort, but it's awful good fun to do. So treat it as a way of improving your flying. The key elements, as I said, accurate flying, minimum control inputs. If you're having to steer the plane all the time along the course, then first of all, make sure that you're actually flying into wind and you're not being blown off the course. But if the plane won't fly in a straight line, then you need to start looking at why. Is the lateral balance of the plane out? Are there actually any warps or twists? And whilst on that subject, if in moving from your normal tests to your speed tests, the plane starts turning, it either means there's a twist in the airframe, therefore the faster you fly, the more that twist becomes effective to turn the model, or more likely, especially with a molded aeroplane, you've got one flap deflected slightly more than the other. So with ailerons and rudder, after you've got the initial dialed in normal flight, there should be no need to touch them to keep the plane in a straight line. So if it does start turning one way or other, first thing, look at the flaps. If you've got split elevators, make sure that they're actually moving together. But the problem is most likely to be the flaps. So make the necessary adjustments, treating the flaps as ailerons. Then when you made the adjustments and you got it flying straight again, go back and try it in normal mode to make sure you haven't upset anything. Then go back to speed mode, measure carefully the flap deflections. If they're out relative to each other, then it looks like you might have a twist in the airframe somewhere and need to look in a bit more detail. But slowly you'll be able to fine tune this so you can fly along in normal mode, drop it into speed mode. The plane will naturally drop its nose just a little tiny bit, start to accelerate with no other input from you at all. Now, this is really important when you start to fly dolphin style around the course, because if you're having to fight the plane as it moves from one mode to the other, then you're basically flying inefficiently, especially if you've got any sort of heading changes, if you change from one mode to the other. Then you're going to have to correct that. That's more control inputs. That's more drag, less efficiency. So once you've got those two dialed in, then you've got to come back to thermal mode. Now here, in discussion with people, a lot of people have got different ideas at how they like to fly in thermal mode. I've come up with a compromise situation that suits me, where I have two thermal modes. The first of my thermal modes is basically finding what's known as minimum sink. So again, by flying out, checking your height, checking your speed, flying a set distance, you can see what your minimum sink of the model is. And I like my first thermal setting to be that. So the plane's as floaty as possible. I'm not trying to cover any distance. I'm trying to be as floaty as possible so I can loiter around in the thermal most efficiently. And this is important if you're porpoise flying and you're flying in a straight line through lift. You can whack it into thermal mode. It will balloon up a little bit. Again, making sure there's no heading changes by having wrong flap deflections or anything like that. And then you can sort of loiter in the thermal for as long as you can hear the uptone of the vario. As soon as that vario tone starts to disappear again, you can whack it back into normal mode or even speed mode. The plane will naturally accelerate and fly away again. So that's how I use my normal thermal mode. But I also have a thermal 2 mode, which I have found to be very, very useful. And fundamentally, it's thermal 1, but the plane is over elevated, which may sound a bit contrary, but what it basically means is in my normal thermal turn diameter, there's enough up elevator dialed in thermal 2 to keep the nose up without hanging on the elevator stick. Now, this is especially important if you're flying the model really high or a long distance away, where it's quite difficult to see what the aeroplane's doing. If you've got this thing set up such that with a given amount of bank on, there's enough elevator programmed into it to keep the nose up without you having to hold up elevator in, you can basically bank the plane over and let it do its own thing. And it's much easier to see bank angles than it is pitch angles on your average glider. So if you keep the bank angle constant, bearing in mind that you want to drift downwind with this thermal, so there's not huge reasons to be constantly changing the bank angle once you've centered on the thermal. I find this thermal 2 mode means I can climb much more efficiently in a thermal just by watching the bank angle rather than having to control the pitch angle, which is very, very difficult to see. Does all of that make any sense, guys?
Yeah, it's really good, John. Yeah, so are you talking, do you have the same sort of setup in any of your gliders, like your scale and your sports class?
Yeah, basically between my sport class and my scale class, I try and have the setup of the models very similar. Yeah. I found we all started with the scale class, although I started with the self-launch version.
Yeah.
When sport class came along, I really took to it because it was like a slightly mini version of scale flying. Therefore, I set up my sport class models in the same way I set up my open class, my scale class models. So they have a very similar flying style. And actually, with my 8.4 metre span scale class model and my 4 3/4 metre span sport model, they visually look pretty similar on the course, because obviously the sport class course is smaller, and their flying styles and even their lap times are pretty similar. Now, everything I've said so far fits in really nicely with the sport class and scale class. I've started playing with the open class, the light class, and I think the techniques there are going to be slightly different. Basic model setup and trimming is exactly the same, but the limited energy that the light class models have, and flying closer to the ground normally, where certainly in the UK the air can be more turbulent, I think we're going to see a slightly different setup needed to get the best out of the light class models. But certainly what I've talked about so far, it is a lot of work. You're not going to dial a plane in a couple of early morning sessions. You'll certainly be heading in the right direction, but the time spent getting them dialed in is absolutely invaluable. And there's also a big safety issue in this. Having the CRG right and the trim settings, especially in speed mode, correct, means the plane is unlikely to get away from you. Now, when I first started running training courses over here in the UK, unfortunately, on the first 3 training courses, 3 fairly experienced aeroplane pilots lost their models. And in one case, it was because it got away from him in speed mode. He was flying with the CRG slightly too far back and not completely dialed in to trim. He got it into speed mode and hadn't realised, because he was flying at height, that the plane was actually getting steeper and steeper and steeper, therefore faster and faster and faster. By the time he realised, it was going way past VNE, and in his attempt to pull out, the plane broke up. When you're flying seriously high, that is a risk. Following my guidance on CRG checks and getting it dialed in at flying at a lower level where you can see things will stop that actually happening. Because if the plane does get away from you and start diving, it will slowly start to pull out, even if you haven't recognised the situation. You should actually also be listening to the vario, and you should hear what's going on. But as John mentioned right back at the beginning, with everything else going on the flying field and trying to concentrate on flying the plane, and there's somebody running an engine behind you, and there's a light aircraft just to fly into your area, which is a problem we have in the UK all the time, despite our NOTAMs. It's very easy to miss that, and the plane gets away from you. John, anything to add?
Yeah, that's right. Well, that's the whole, it's the whole thing that you have to, have everything, like you said, have everything right. And for me, as I said, going from flying a scale glider into going to fly GPS, that trimming stage, as you said, it was a lot of flying. The reason we do this hobby is to do a lot of flying, and it's absolutely great. For me, it's probably the most enjoyable part of it. I mean, apart from obviously flying triangles with other people, it's a very enjoyable part, because, say, for here in Australia, I've done most of my testing just before, like at dusk, and it's just absolutely beautiful. You're out there and it's dead calm, and there's, the sun's going down, and you're just flying this glider back and forth and really getting some performance out of it. And for my latest glider, I've really I've really changed the way the whole thing performs, to the point where when I went to, in the last Worlds, I think I was flying around with Andre, and we had like a dead calm end of day flight where everyone was just circling around and just flying the laps basically as cleanly as possible. And I can remember that I had my glider probably the best. It was probably one of the best flights I've ever had, most enjoyable flight, because I was basically in a straight line. I was just flying that glider on a trim. There was a very slight breeze, I think, flying down the strip. So in the strip, I'd click the elevator one click, going down to turn 2, I'd click it back a click and just do the turns. And we did, I think we did 4 or 5 laps like that. And it was just absolutely magnificent. And, you know, without doing all those flights, as you said, there's no way that the glider would fly like that. It would be all over the shop. And as I said, for me, it was a very enjoyable part. Dave, do you have any questions so far?
Yeah, there's a couple there. If I could take them one at a time. Matthew Smales asks, what causes the glider to gently rise and fall when flying straight and level? Is it the centre of gravity, camber, or his bad flying?
Well, I know Matt because I fly with him, so I'm going to say it's all 3. But I've sort of touched on this one. Any or all of those can cause the problem. If it's flying too slowly, it's over elevated, that will cause the problem. So the first thing to do is go back to the COG check. Do the COG dive check. Maybe you've set it up so it's pulling out a little bit too quickly. It's coming out towards straight level flight a bit too quickly. So you might think about nudging the COG back if you think the plane was already flying fast enough. So that would be my first check. The second one, of course, is to go back and do this calm air test. Try dialing a little bit of a couple of notches of down elevator in. If that doesn't help the situation or makes the situation worse, then it points to the COG. And the third thing, of course, is keep off the elevator. If your plane is flying in a straight line and you're not trying to turn, then there's no need to be touching the elevator at all if the plane is trimmed correctly, because anything you do with the elevator, up or down, is only going to make matters worse.
Yeah, I was amazed after flying scale gliders how much noseway I could actually pull out the glider. It was just amazing, like doing those calm flight checks to see how much you could move the CG aft. It was incredible. I've been blown away by that too. And that's all positive because you're pulling weight out of it.
Just be careful though, John, that you don't go so far back that in your dive tests, it doesn't start to pull out. That can be risky.
I take it out very gradually. I've been doing it. Yeah, no, it's all good. Good fun.
Another question from John Minchell for JEG. How do you determine the extra elevator setting needed for thermal 2?
Oh, that's very simple. I do thermal turns at low level. I'm using a flight mode for thermal 2, and the trims are separated in my flight mode. So what I will do is again, best done on a calm day, but I will start some thermal turns quite low, maybe only 20, 30 meters up. And whilst it's circling, I will basically be putting up trim in it until it will basically circle hands off. So it's as simple as dialing it in that way. The important thing to remember if you're flying in thermal 2 is you really need to come out of thermal 2 before you stop turning. Because if you straighten up, the plane will be over elevated. It'll almost certainly, because you're flying quite close to the stall in thermal flight anyway, it will then stall, drop its nose, and all your hard work in the thermal will be lost. So again, a technique, start the turn, then go into thermal 2, come out of thermal 2, then straighten up. Now, thermal 2 might not work for everybody, but I know quite a few people who are now using it, and I find it really effective, especially, as I say, when it's difficult to see the plane because of light conditions or height or overcast or haze. It just means that you can leave the plane to do its own thing. The other advantage of leaving the plane to do its own thing is it gives you more time to concentrate on what else is going on. Is there some decent weather coming? Is there some bad weather coming? Is there some clouds building up wind?
Is there a bird thermaling behind you?
Is there a bird thermaling behind me?
Yeah.
Being able to, what I refer to as park the glider and concentrate on other things is invaluable. It may even be just what's everybody else doing? Are they doing better than me? Are they circling over there? So it's a very useful tool in my mind, but the best thing to do is set it up flying low so you can see what you're doing. But obviously, one must stay high in case you put too much up elevator in your stall while circling.
It's a great answer. Thanks, John. And I'm going to try that myself. I know early on in my full-size flying, we got lectured not to trim the aeroplane in a turn, but particularly in our model aeroplane flying where you can just flick a switch and you're in that thermal 2 concept, and then you can settle the aeroplane down in a thermal. I really like that idea. I'm going to try that myself.
I also actually use, very, very rarely in the UK, but I have a speed 2 setting as well, which is really pushing the plane on. It's very rare in the UK we get conditions where you need it, but I have had situations where the lift is booming, I'm already high, and I don't want to go any higher. So I just want to get a move on and basically try and fly level. And I have a speed 2 setting, which is quite complicated to set up because you can only really set it up when you're in booming conditions. And what's booming conditions? Is it 2 meters a second up, 3 meters a second up, 6 meters a second up? But I do have this setting which basically leaves the camber where it is, but it dials in a bit more down elevator. And if I get this situation, as very fortunately I had momentarily yesterday, I was up at about 600 meters with a sport class model, and then I flew into some lift. Now I didn't want to go any higher, there was no need to, the clock was running down. So I could whack it into speed 2 setting, which is better than trying to fly leaning on the elevator. Leaning on the elevator, it's very difficult to fly accurately. And there's a chance again that you lean too much on the elevator and it's inefficient. So a speed 2 setting is something, after you've done all these other settings, you may want to consider if you've got the relevant flight modes and you can get your head around what you're doing.
Yeah, well, it's difficult to fly consistently, isn't it? If you're playing with the sticks all the time, whereas if you have it in a flight mode, it's going to be consistent. You know what it's going to be. So you can
Absolutely, John. That's the key to everything. Consistent flying.
Absolutely.
And consistent flying is best done by not waggling the sticks.
Yeah. I think Bill's got a question.
Okay, Bill. Bill?
No, they didn't want to talk.
It's normal process for me with my F5J models and F3J for that matter. And I do use thermal 2, but the one thing I've found with thermal 2, if you're pulling it sort of pulling a reasonable amount of elevator in the thermal 2, it's wise to, well, I found anyway, it's wise to use thermal 2 when you know the lift is strong. If the lift is weak and you go into thermal 2, you may well find yourself stalling the model.
Good point, Bill. Thermal 2, like every other setting, is a compromise. I tend to get my thermal 2 setting delivered, controlled via the bank angle. So if you've got a really small punchy thermal and you've got a bank tighter to stay in it, then of course you will need some elevator. And you've also got to be careful that if you need to flatten out a turn while you're in thermal 2, then effectively your plane will be over elevated. So it's a tool that needs to be used with caution, but it can be invaluable.
But what you can do also is set up several different model memories, like one for calm, one for windy, one for not so windy, and then you choose that before you go fly, and you can have all your different trims within those model memories, can't you? So
can do, John, but I tend to do it slightly differently.
Yeah.
Because I have 2. I used to have 3, but it got more complicated than it needed to be. But basically, all of my models, they have the ability to put ballast in them. So I have a light setting where I go through this entire trim process of all the flight modes, CG, absolutely everything. And then without changing the CG, making sure that the ballast, when you put the ballast in, the CG is in exactly the same position, which can be quite difficult actually. I then have a heavy setting where I've been all the way through this process again, trimming the model to fly fully ballasted. And I will make the decision on any particular day, am I going to fly with ballast or without ballast? So rather than calling it a windy setting or a calm weather setting.
Yeah.
Basically, I've got two models with two different setups,
right,
depending whether they're flying heavy or light.
Yeah, same sort of thing, just a different name, isn't it? Yeah. Have we got any other questions, Dave?
Not at this stage.
Okay.
John.
Okay.
John.
Yeah. Oh, which John?
Which one?
Both of you.
Yeah.
Gavin Bowden. What Bill said is quite correct with F5J and F3J. Exactly what you've said is the way that the experts tell us to set them up. But one thing I've found is that with your so-called Speed 2, particularly, you have to watch that you don't end up with a model that won't pull out of the dive.
Very true, Gavin. I did say slightly earlier that I was fundamentally talking about the scale class and the sport class.
Yes.
These planes are pretty strong, pretty robust things. The technique's going to need tweaking a bit for the light class. You've got less altitude to play with. You've got less energy in the model. The models are generally a bit weaker in construction. So yeah, it is an issue. It's always a compromise. But if you're going to start playing with speed settings or Speed 2 settings, err on the cautious side.
Yeah, I'm not talking so much about the model breaking. Is that it won't pull out of the dive on its own.
Yeah.
Unless you should make sure if you set that up that you've checked the dive test again on that setting.
Okay, that's interesting because if your CAG's in the right position, the increase in airspeed should slightly generate more lift, so it should start pulling out unless your CAG was too far back to start with.
Well, I would challenge that because I think that the thing is that to get that extra bit of speed, you put a bit of down elevator, and then you've got just haven't got the downward pressure on the elevator, and also you're changing the flap and aileron trim.
Then you might be better off changing the camber more and staying away less elevator.
It's when you change the camber is the problem, because if you reduce the camber of the flaps, then the down the bending of the airflow downwards onto the elevator and stabilizer is less.
Okay, well,
I've done a lot of testing with that with a 2 meter full house model, and that's exactly what it does. If you pull the the flaps up to almost reflex, that's when you're in trouble. Believe it or not.
Then you might be better not reflexing the flaps so far. But you're fundamentally right. Be careful that you don't end up with a plane that wants to tuck on you, because that's moving way away from efficiency.
Yeah.
And obviously you're losing a lot of height as well.
And what I'm saying is if you're trying for that extra speed setting, that's what you've got to watch. You go back and check it.
Thank you, Gavin.
Thanks, Gavin. I've got a picture of John's sports class model, which I'll just show you. This is it is called the John Greenfield Special.
It actually isn't. It's called a GPS Special.
Okay. But didn't you?
I had a bit of a hand in the concept and design with Bernie Jones and Valenta, but it's fundamentally the shape of a Valenta Chili, but it isn't a Chili. It's completely different. Right. You notice in that picture, it's got air brakes in it. The construction and layout is completely different and much, much lighter. The latest ones have got spread carbon wingtips. It's got facilities for ballast inside it. And the one that I'm actually holding there, which is my new one, that actually comes in at under 5.5 kilos.
Okay.
And it will take 1.5 kilos of ballast.
Yeah, right. Okay.
Now, to put that into perspective, the still air glide, my normal glide speed on this plane is around about 58 kilometers an hour.
Okay.
With 1.5 kilos of ballast in it, its nominal glide speed is about 85 to 90 kilometers an hour.
Yeah, right. Okay.
So it makes a huge difference.
Yeah. Okay. All right. Well, thanks, John. Have you got anything else to add, or?
No, I'm just having a quick flick. Is there any more questions, David?
No, not at this stage.
Okay.
Perhaps one from me. John Copeland, your ASH 31 is the same size as mine, about 7 metres.
Yeah.
What is yours weigh with both with an SLS config, or if you were just aero towing it?
Oh, well, mine's the same either or, because it's just got a prop drive in the front with a removable propeller. So I've got the weight down to 16.3 kilos.
Oh, yeah. And do you take the motor batteries out when you're aero towing?
No, because that's part of the nose weight. Yeah.
Oh, that's what mine weighs, so we're not. That's good to know. Thank you.
Okay. Yeah, no worries. Yeah. All right. So yeah, one thing I want to add, like I've been doing thanks, John, anyway, for your talk. It's good.
No worries. I've got a couple of things to add if we're winding up.
Yeah.
First of all,
I wasn't going to
Andre,
straight away.
Andre is running a Zoom session on Sunday evening in European UK times on setting up the Albatross unit of his, which I'm really looking forward to, because it's a hellishly powerful thing, and I'm sure I'm not getting the best out of it. That session will be recorded, but if you go onto any of the Facebook forums, he's been advertising quite. I think he put something up on the Australian GPS.
And the last one that he did last week, I advertised that also. That was really good. He talked about setting up snipe and raven and finch and sparrow, and a little bit about albatross, and they were really, really informative sessions. And I'll put a link up to that, and also when he will do a recording, and then he puts a YouTube link up, so I'll also put that on the GPS page, the Australian GPS page also. So just
for those of you outside Australia, I've put a link up on the UK site as well to it, so you can find it for Sunday evening. But I commend you to listen to that one.
Yeah.
I also commend, John Copeland started off the same as me. When I started flying GPS flying, there was nobody in the UK doing it at all. So it was a steep learning curve. I think John will agree.
Yeah, absolutely.
Also, given the fact that in the early days, the kit was not nearly as reliable as it is now.
Yeah.
But I commend you when you can, and obviously with social distancing and staying safe and everything else, to try and meet up with fellow guys and fly together, because there's always things to learn. Keep your eyes on the forums as well, because occasionally questions pop up, and it's worth reading the answers. And secondly, don't be afraid to ask a question. We're all still learning in this game. I've been doing it since 2011, and almost every single time I go flying, I learn something new. And I'm fortunate that I've got a couple of guys in my club now who are flying. They're fairly new to it, but they ask questions that leave me thinking, oh yeah, well, what about that? Yeah. So the new guys can teach the old guys new tricks as well. Yeah. So don't be afraid of asking questions. Just because we've been doing it for a while doesn't mean we're doing it right.
No, absolutely not. No. Well,
one of your English colleagues has absolutely mastered it. It's a guy called Bernie Jones who says that he has struggles to stay awake on the field, and I wonder if that's because he's so good that he can just do it in his sleep. Or
well, I know Bernie, so I'm not answering that
one. He's probably got his conditions set that well from John's training that it flies around the triangles on its own.
That's the answer.
Yeah.
Fantastic.
Yeah, no, thanks, John. It was really good. One thing I've found lately is I've been, the last couple of weekends, I've been doing a bit of light class flying. And that, for me, because as you could see, prior, when I first started with GPS, I was quite addicted to it. The ridiculous things I used to do are probably not quite to that extent now. But with light class, for me, that has really stimulated new interest. I think it's fantastic. And there was discussion on one of the Zoom sessions with the Europeans, I think, that they said that they were having a few issues with people complaining that the 350 metre height limit is an issue. I actually found that to be another level of control over the whole thing, and it actually makes it quite good because as you Australian guys will know, we get big weather here. It'd be quite easy to punch through that 350, but you need to put your nose down and just do triangles. to stay there. It just really adds another level of excitement. For me, it works really well. And what I've done with the conditions on my F5J glider, for instance, is for speed. All as I've done when I flick speed mode is I just back the controls right off. So it basically just flies very straight, and I have to put big stick movements in it to get it to move a little way. So it actually flies nice and neat around the course. Otherwise, it seems a bit twitchy. So, but for me, yeah, that's really stimulated some. It's really got me interested in doing some GPS again. So it's really good.
John, that's a very good point that you've mentioned there, which actually I've got a note here and forgot to mention. When you're flying in speed mode, and I have this set up when my heavy setup of my models, in speed mode, I also have my control throws reduced.
Yeah.
So there's less chance of overstressing the model, especially when making the turn.
Yeah.
Because if you're approaching the turn at 200 kilometers an hour, especially at height, it's very easy to overstress the model.
Exactly.
So I actually have my primary controls, ailerons, elevator, and rudder, actually reduce sensitivity when I'm flying fast.
Yeah. And what I've done also is, if you're flying fast down the straight, as you come to the turn, I might flick it into normal mode just for a split second, just to crack it into the turn, and then straight back into speed mode again and continue on. That seems to work really well too, because it gives you a bit of a pull up and also, you know, get around the turn nicely.
Yeah.
All right. So this has been our third session. Really appreciate everyone's feedback, and we're probably going to be open to some suggestions if you want us to do another one, if you want us to do another session. So if you have a particular topic that you'd like us to talk about, or if you'd just like to have an open session where we can just discuss. I know there's now, thankfully in Australia, there's some guys buying some gear. So I think once the shutdown process happens, I'll actually be able to go and do some GPS with some other people in Australia, which will be fantastic. Yeah, if you've got any suggestions of what we could do for another Zoom session, if you want another Zoom session, just contact us, and yeah, we'll put something together. So yeah, I'd like to thank everyone for coming along, and thanks again, Dave, and thanks, John.
Thanks for setting it up, John.
No worries.
I think we've all learned something today.
Yeah.
I echo that. Thanks very much, both of you. And if I could pass that on from everybody else that's been listening tonight, I'm sure everybody's really enjoyed it and got something from the session.
Yeah. Okay. Thank you. Thank you, everyone.